Algebra 2 students, in this video we will be adding two more functions to our list of functions that we know how to graph already. Now these two functions are square root functions and cube root functions. So obviously your heading will be graphing square root and cube root functions. Lesson 7.6, and please include today's date. Now, I say this quite regularly. I would use a nice spiral bound notebook or a 3-ring binder or something. Keep these notebooks for years to come, okay? They will help you review your math when you need to, okay? Alright, here we go. Like usual, let me start off by showing you what these functions look like. Please write down these examples. Now the video today is not very long. I'm going to move pretty quickly because the math is not difficult, okay? This would be a square root function. Please write this down. It is not a square root function just because it has a square root in it. It has to have a square root, and there must be a variable inside the square root. That's what makes it a square root. Got it? It must have a square root, and there must be a variable inside as part of the radicand. Remember, the radicand is everything under the radical, so your radicand must have a variable in it. Please copy this down. If I go too fast, just pause the video. This is a cube root function. It is not a cube root function just because it has a cube root. It must have a cubed root, but there also must be a variable in the radicand. Alright, for example, this would not be a square root function. The only thing under the radical is 5. In fact, this is a linear function. Okay? This would not be a cubed root function. With an x right here, because there's no variable under the radical, you must have a square root with a variable inside, or a cube root with a variable inside. Okay? Now, remember there's a 2 here, and remember this entire expression is to the what power? 1. There's a 3 here, and this entire expression under the radical has a power of what? 1. Why are you telling us that, Mr. Earhart? Because remember, they could also be written like this. Remember, here's your power of 1, and there's a 2 here. So x plus 3 to the 1 half power. This x plus 2 has a power of 1. So we can say x plus 2 to the 1/3 power. I remember specifically telling you guys on the day that we talked about your exponential properties and the day we talked about rational exponents that you would use this in all your future math. You must get used to radical form and fractional or rational exponential form. Look this over and understand how to go back and forth. Because this is a square root function, because 1/2 is really a radical. This is a cubed root function, because this is really a cubed root. Please understand that. Alright, look it over, make sure you get this. Now, I want to show you what the general shape of each function is. So please take really good notes on this. You need to know this. Alright? Let's start with a square root function. I'm going to give you a lot of notes or a lot of comments. So write this. I will tell you what to write down, but please listen and write it down. Okay, so let's talk about square root functions first. Okay, so put the coordinate plane under your square root functions. A square root function is half, I would write this down, of a sideways parabola. That's the best way to describe it. Half of a sideways parabola. Okay? I would write that down. A square root graph, a square root function graph is half of a sideways parabola. Now let's remember, don't write this down, just watch. Here's a parabola. Remember that? Now if you cut that in half, well, I sure didn't mean to do that. If you cut that in half, it would look like that. That's half of a parabola, right? Sure it is. So, what we're looking for is half of a sideways parabola. So a sideways parabola would look like this, and then half of it would be like from here to here, and this part here would be gone. So write this down. A square root function's graph it looks like a half of a sideways parabola. So it could look like this. It could look like this. It could face this way. It could face this way. Are you getting all of this? Write this down. It could be a real wide one like this. It could be a real narrow one like this. Okay, just like parabolas can be narrow and parabolas can be very wide. Okay, so a square root function, the best way to verbally describe it is it's half of a sideways parabola. It can go this direction, it can go down and over, up and over, down. It can go to the right, go to the left. All of these are possibilities. Well, Mr. Earhart, what makes them do this? Well, a negative or a positive sign out here influences which way it's going, and also a negative or a positive X right here influences which way it's going. So I won't get into all of those details now, but that's what influences which way it's going and whether it goes up or down or right or left or whatever. Got it? Now, let's talk about what a cubed root functional graph looks like, okay? Well, you could kind of say it looks like an S, only kind of stretched out like this. I have to be careful saying an S, because an S comes back and then down. And it doesn't do that, okay? It comes down, and it goes like this, and it goes like this. Now, it's almost like two half parabolas intersecting, like you have a half a parabola going up, and then the other half going like this. That's what it looks like, okay? Now, this part here is never a straight line. It'll have a curve to it. Some will have a real gradual curve, and some will be sharper, but it will not be a straight line, okay? So, the graph can be really skinny like this with a little curve, or it can have a really wide curve, okay? It can go this direction like this, okay? Or it can start up high and go like this, like that, okay? Either one of those would be fine. They will not go up or down like this. They will not, at least not in this part of the book. Now later, if we get the Y's and the X's swapped around, that's different, okay? But for right now, they will go to the right and to the left. So over here, there were 4 different possibilities. Let me get rid of this. That was an extra one. Over here, there were 4 different possibilities of directions. Over here, there's just 2. One that starts up and goes like this, and one that starts down and goes like this, okay? That's it. So that's what these graphs look like. So if I'm going too fast, pause the video. I'm not trying to rush. That's just as simple as it gets, okay? Over here, you have, I never really thought about using words for this, but to be honest, I like what I said a second ago. This is like 2 half parabolas being joined right here. Here's your half parabola, and there's the other half going this way, okay? Over here, you have half of a sideways parabola. Here you have 2 half parabolas joined right here. That's exactly what it is. There we go. Or it could look like this, like I said earlier. Like this. And like that. Okay, students. Alright, let's continue on. Now, we're going to look at only one example of each type of function. When the math is simple and all that you need is practice, then I want to give you plenty of time to practice. Of course, by practice, I mean homework. And I think you guys can appreciate that I'm not going to bore you with a long video when it's just not necessary. I want to give you as much time as possible to work on your homework, so hopefully a lot of it will be done in class. So that's why I'm going to give you only one example of each type, okay? They're really cut and dried, guys. They're not difficult as long as you use the steps that I give you. If you do that, you will be totally fine. They are done a little differently, so please pay close attention to each one, okay? Each one is done a little differently. The square root compared to the cube root. Okay, here are the steps. I'm going to go quickly. You'll have to pause the video and copy these down. Set the radicand equal to 0 and solve. We're going to start off with the square root function. I think I said that. Take the answer from step 1 and put it at the top of a table of values. Put 3 more x values into your table of value. Make sure you go the right direction with your numbers. Find the y values also. I should have included that in step 3. Find the y values also. Let me go back to step 3. That's my fault, sorry. Put 3 more x values into your table of value. Make sure you go the right direction with your numbers. Find the y values also. Now, go the right direction. I will explain that in just a minute, okay? Plot the points and sketch the graph. And that's it, guys. That's it. So, pause the video, copy these down, then restart it. I'm going to move on, okay? Now, here's our first problem and our only problem we're going to look at. And I should have put this also. Find the y values also. I left that off right here. Find y values also. Don't worry, you have that in your notes. It was right over here. So you guys already have that, okay? Alright, here we go. Now, so here we have a square root function. Don't forget it could have been written like this also. That would have been totally fine because this whole thing here is to the 1 power and there's a 2 right here. So either one of those would be acceptable. You'll have both of these kinds mixed into your homework when you do homework over this lesson. Okay, set the radicand equal to 0 and solve. Here's my radicand. Isn't that easy? How many of you cannot take that and set it equal to 0? That's easy, isn't it? Bring the 3 over and make it positive. Boom, step 1 is done. Now guys, there is the only reason someone won't do that on a test or a quiz is because I'm going to be a little blunt with you, is you might be a little lazy and not learn your steps. That's the only reason. All of you in class can take this, set it equal to 0 and solve. Everyone can do step 2. Take your answer from step 1. What was my answer from step 1? 3. And put it at the top of a table of values. So here's your table of values. Put it at the top. Isn't that easy? Piece of cake. How many of you cannot do that? Now put 3 more x values into the table of values. Make sure you go the right direction. Now, when I said make sure you go the right direction, from 3, on the other side of 3, here's a number line. On a number line, 4 is beside 3 and 2 is beside 3. So do you want to put 2, 1, 0 for your next 3 numbers? Or do you want to put 4, 5, 6? What do you want to put? Well, here's how you know. Now I hope you're listening. Here's how you know. Look at the 2 numbers. You could put a 2 or you could put a 4, right? Here's your 3. You could put a 2 or a 4. Well, guys, one of these numbers will give you a negative radicand. One of them will give you a positive radicand. You know you cannot take the square root of a negative number. So whichever, and Mr. Arrow, one of these always give you a negative number. Always. If this is right, if you did step 1 correctly, always one of these numbers here will give you a negative number. And obviously it's 2. If you put 2 in for x, 2 minus 3 is, well, negative 1. And we can't take the square root of negative 1, correct? So, obviously I'm not going to use 2. So the direction I want to go then is 4. And sometimes I skip a couple numbers. I want to encourage you to do that to get a bigger picture of the graph. Maybe jump up to, I don't know, 6 and then maybe 9. Just a thought. I think it gives you a wider. I want to encourage you strongly to do that. So I'll take a side note somewhere. It gives you a broader view of the graph so you get that curve in there somewhere, okay? So I want to encourage you to do that. So let's review. Take the radicand, set it equal to 0 and solve. Well, that's simple. Take that number, put it up top. That's easy. And then decide, am I going to go to the left of the number or to the right? Well, you decide by saying which one of these numbers gives you a negative radicand. Whichever one gives you a negative radicand, that's obviously not the direction you want to go. So we know we're going to go in the direction of 4, and I would skip some numbers and kind of spread them out a little bit. So there we go. Really, really simple so far, guys, okay? So we've done everything except the last part of step 3, which says find the y values also. So let's find the y values using a calculator. Alright, so here we go. I'm grabbing my calculator right now. And here we go. Um, put a 3 in. 3 minus 3 is 0. The square root of 0 is 0. Alright? Now put a 4 in for x. 4 minus 3 is 1. Right? Put a 4 right here. 4 minus 3 is 1. The square root of 1 is 1. Now let's put a 6 in for x. A 6. Well, 6 minus 3 is 3. And the square root of 3 is 1.7. Now put a 9 in for x. A 9. Well, 9 minus 3 is 6. And the square root of 6 is 2.44. Now I'm going to put 2.5, okay? So there we go, students. Just like that, we have our table of values. Really not too difficult at all. I'll have to add a couple more points to my x-axis to get a 9 in there, but that's okay. So 3, 0. There we go. 4, 1. There we go. 6, 1.7. A little bit of a curve already showing. That's good. And then 7, 8, 9, up to 2.5. So about 2.4 really. So right there, there's my graph. Now, I need to talk to you guys about something. I hope you're listening. Let's go back to way back here where I was showing you what the graph looked like. Did you notice I didn't put arrows on either end? I told you it was half a parabola. Did you notice that? Remember? Well, I'm not the best teacher in the world, but there was a reason I had you put this point at the what? Top. There's a reason. Are you listening? That's because whatever your top point is, that's where you want to start. And then go to the other points. Do not go like this and put an arrow on this end. If you do that, I will definitely take points off. Remember I showed you, you cannot go to the left of 3. You cannot go to the left of 3. Because if you go to the left of 3, you'll get a negative number. If you put in 2.9, you'll get a negative 0.1. Okay, you cannot go any further. I'm going to put an imaginary boundary here. Now, if you put that in your notes, make a note to yourself that dotted line's not really there. It's make-believe, okay? But this graph cannot go past this boundary. It can be on it, but not past it. So with a square root graph, always put your pencil on the first ordered pair here. Now guys, I hope you'll not think that I'm rushing. I'm trying to say to you, look, you don't need teaching. You need to take these notes and practice about 5 or 6 of these, okay? That's what you need to do. They're not difficult. Anyone can set a radicand equal to 0 and solve. Then put that number up here, then put points here, numbers here, and then graph the function. It's not difficult, but you need to practice it, okay? Alright, and that's why we're covering both of these in one lesson, because they're pretty simple. Now, on to graphing a cube root function, okay? Here are the steps. Set the radicand equal to 0 and solve. Piece of cake. But here's where it gets a little different. Take your answer from step 1 like we did before and place it not at the top but in the middle. Now stop. Stop. Think about this. Was not the square root graph a half a parabola? That's why you put it at the top, because it starts and goes. But remember, the cube root graph continues both directions, so it makes sense. You want that pair to be right in the middle, right there, which then gives you a curve this way and a curve this way. Okay, it does make sense. It really does. Okay, so for a cube root function, you're going to take your answer from step 1 and place it in the middle of your table of values. Now for this type of function, you will have a total of 5 ordered pairs, just like a parabola, 5 ordered pairs. Fill in the other x values along with their y values, and then plot the points and sketch the graphs. Really, guys? Pretty simple. Okay, I'm going to pull this over here, and I'm not sure why I didn't type the function in, but I'll write it for you real quick. Please copy this in your notes if you would. Are you ready? I'm going to make this one pretty tough. Copy this down, please. There it is. That should be 1/3. Sorry, 1/3. Now, this is a radical, a cubed root function because I have an expression there's an x inside the expression here. Let's rewrite this with the radical, shall we? The 1/3 only goes to the parentheses. So the 1/3 does not go to this 2. So the 2 would go on the outside. Then you would put your cubed root, and then what goes on the inside? 2x minus 1, and then plus 1 on the outside. 3. There. Look it over. Make sure that makes sense, okay? If not, you need to back it up and watch it. It gets real important. It's really important you understand how to take this to this. Very important. Mr. Earhart, where'd the 1 go? Right here. Well, remember, this whole expression here is to the 1 power. To the 1, and anything to the 1 power is just itself. Alright? Okay, so we've rewritten the problem, so now it looks a little more friendly to us, okay? So step 1, take the radicand and set it equal to 0 and solve. Well, here's my radicand. So let's set it equal to 0 and solve. Anyone can do that. There we go. Bring your 1 over and make it a positive 1. Divide both sides by 2. And look at that. There we go. 1/2. Now it says take your answer from step 1 and put it in the middle of your table of values. In the middle. So I know I'm going to have 5 ordered pairs. So let's set this up properly. And so right here I'm going to put 1/2 in the middle. Now, in the last problem, we had to kind of run a test. Remember, here's my number line. Here's 3. Here's 4. Here's 5. I mean 2. And you had to decide whether you were going to put a 2 or a 4. And you realized 2 gave you a negative number, so you put a 4 here. Okay? We do not have to do that here because we're going to go up and down. Now, I want to tell you the same thing I told you in the last problem, and that is spread out your points. Spread them out, okay? So we're at 1/2. Think of a number line. The next number is 1, but I'm going to go ahead and put a 3. Just spread it out, just to spread it out a little bit, okay? And now I put a 6. There's no set way to do this. Just going to spread your points out a little bit so you get a better picture of the graph. Now, from 1/2 going down, the next number is 0. I'm going to go to -2. That's just me, okay? And -5. That's you could use other numbers and you'd be fine. But I'm kind of spreading it out a little bit. Now, let's go ahead and put a 6 in. 2 times 6 is 12. Minus 1 is 11. Okay? So I have 2 times the cube root of 11 plus 3. Now, you should know by now how to get a cube root. I will remind you once how to do that. You hit a 3 first. Don't worry about this 2 right now, guys. Just hold on a second, okay? Hit a 3, then go to math, and then option 5 would work, but there's another way I forgot about. You could also just hit math. Don't put a 3 first, okay? Just hit math, and then option 4, and a little cubed root will pop up on your screen like that. That's probably the best way to do it. So do not put a 3 like I said. Just hit math, option 4, and this will pop up. And then hit 11. Then hit enter. Hit enter, and then hit times 2. Enter. And then hit plus 3. Enter. And you will get 7.44. Alright? Now let's try 3. Let's put a 3 in for x, alright? So we'll put a 3 right here. 2 times 3 is 6, minus 1 is 5. So we have the cubed root of 5 plus 3. So here we go. I'm going to go to math. Option 4 is cubed root of 5. Enter. Times 2. Enter. Plus 3. Enter. 6.41. Now let's try 1/2, okay? Now we already know what we're going to get because we already set this equal to 0. And so if you put a 1/2 in, you're going to get out 0. 2 times 1/2 is 1. And 1 minus 1 is 0. So 2 cube root of 0 plus 3. Alright? Well, the cube root of 0 is 0. 0 times 2 is 0. And 0 plus 3 is 3. So there we go. Now let's go ahead and substitute a -2 in. A -2. Alright? 2 times -2 is -4. And then minus 1 is -5. So I have 2 cube root of -5 plus 3. You cannot take the square root of a negative number, but you can take negative radicand. It's totally fine. Okay, so here we go. I'm going to hit math option 4. That's cubed root, and then negative 5. Enter. Times 2. Enter. Plus 3. Enter. And I'm getting negative 0.4. Negative 0.4. And now I'm going to substitute negative 5 in for x right here. And let's see what we get. 2 times negative 5 is negative 10. Minus 1 is negative 11. So 2 cubed root negative 11 plus 3. So I'm going to type in the cubed root of negative 11. Enter. Times 2. Enter. Plus 3. Enter. Negative 1.4. And students, we are really ready to graph our cubed root function. And that'll be it. What you need to do is practice. Okay, 6, 7.4, so over 6, and up 7.4. 3, so over 3, then up 6.4, so about right here. Over half, and then up 3. See a pretty big curve there, don't you, coming down? Negative 2, negative 0.4, negative 5, negative 1.4. So this is always the middle. Your middle value is right here. I would always start there if I were you. Draw like half of a parabola like this. And then draw the other half coming down like this. And there we go. We just graphed your first cube root function, okay? Guys, I hope this video has been a help to you. I want you to really practice on your homework. It's not difficult, but I want you to really understand how to do this and make sure that you have these steps really down in your head. You can graph these pretty quickly, okay? If you have any questions, don't hesitate to call or email.